Hi everyone, in this video we are going to prove the MN theorem, which is also known as the ratio formula. If we have a triangle ABC and D is such a point that divides the side BC into the ratio of m:n, and AD makes an angle theta with the side BC, and angle BAD is equal to alpha and angle DAC is equal to beta, then we have to prove that m plus n times cotangent of theta is equal to m times cotangent of alpha minus n times cotangent of beta, and also m plus n times cotangent of theta is equal to n times cotangent of the B angle minus m times cotangent of the C angle. This is called the MN theorem or ratio formula. So let's get started with the proof. If you look at the triangle ABD, the sum of the three angles would be equal to pi radian. That means angle ABD, which is the B angle, plus the angle BAD, which is alpha, plus the angle BDA, which is actually pi minus theta, and this sum is equal to pi radian. And if we remove the parenthesis, we are going to get B plus alpha plus pi minus theta is equal to pi, and the pi on both sides will cancel out each other, and from here we can keep B on the left hand side. So from here we can say then B will be equal to theta minus alpha. Also, if you think about theta, theta is actually the exterior angle for the triangle ABD, and it will be equal to the sum of the two farthest interior angles, which are alpha and B. So theta is essentially B plus alpha, and then B can be written as theta minus alpha. And what about C? Well, C can be written as pi minus theta plus beta, because angle C plus theta plus beta, that is equal to pi radian. So C can be expressed in terms of theta and beta as pi minus theta plus beta. Now let's use the sine law on triangle ABD. So we can say BD over sine alpha will be equal to AD over sine B, and from here we can say BD can be written as K times M over sine alpha is equal to AD over sine of B. In place of B, I am going to write theta minus alpha. We have already proved that B is equal to theta minus alpha. The angle B is equal to theta minus alpha. So that's exactly what I did here. Where we had sine B, I am writing sine of theta minus alpha. So what would be the value of Km? Well, Km will be equal to AD times sine of alpha over sine of theta minus alpha. Next, I am going to use the sine law on the triangle ADC. So if we use the sine law on the triangle ADC, then can we say that DC over sine beta is equal to AD over sine C? And from here, in place of DC, I am going to write K times N over sine beta is equal to AD over sine of, in place of the angle C, I am going to write pi minus theta plus beta. We have already proved that on the left hand side. So here I am going to write pi minus the sum of theta and beta. And from here, what would be the value of K times N? Well, that will be equal to AD times sine beta over sine of pi minus theta plus beta, that can be written as sine of theta plus beta, because sine of pi minus any angle is equal to sine of that angle. So we can write it as sine of theta plus beta. Now let's divide Km by Kn. So we are going to divide both of these equations here. So from here we can say then K times M over K times N can be written as AD times sine of alpha over sine of theta minus alpha divided by what is the value of Kn, that is actually AD times sine of beta over sine of theta plus beta, and this can be written as AD times sine alpha over sine of theta minus alpha times sine of theta plus beta over AD times sine of beta. And here if we look at the left hand side, the K in the numerator and the K in the denominator, they will cancel out each other, and similarly AD in the numerator on the right hand side and AD in the denominator, they will cancel out each other. So from here we are going to be left with M over N can be written as sine alpha times sine of theta plus beta over sine beta times sine of theta minus alpha. Now I am going to expand sine of theta plus beta and sine of theta minus alpha. So this can be written as sine alpha times, in the numerator it would be sine alpha times, we are going to get sine theta cos beta plus cos theta sine beta over, we are going to have sine beta times, it would be sine theta cos alpha minus cos theta sine alpha, and next I am going to remove the parenthesis. So this can be written as m over n is equal to sine alpha times sine theta times cos beta I am removing the parenthesis now. So sin alpha will be multiplied with each of the terms inside the parenthesis. So the first one will be sin alpha times sin theta times cos beta, plus the second term will be sin alpha times cos theta times sin beta, and all of that over in the denominator we will have sin beta times sin theta times cos alpha minus sin beta times cos theta times sin alpha. Next, what I am going to do on the right hand side, I am going to divide the numerator and the denominator by sin alpha times sin beta times sin theta. So each of the terms in the numerator will be divided by sin alpha, sin beta, sin theta, and similarly each of the terms in the denominator will also be divided by sin alpha, sin beta, sin theta. So essentially it's going to look like this. As you can see, I have divided each of the terms in numerator by sin alpha times sin beta times sin theta, and similarly I have divided each of the terms in the denominator also by the same quantity, which is sin alpha times sin beta times sin theta. So now if we simplify this, what it's going to look like? Well, if we carefully look at it, you will see that this sin alpha right here will cancel this sin alpha, and then this sin theta will also cancel this sin theta, and then here this sin alpha and sin alpha, they will cancel out each other, and then this sin beta and sin beta, they will also cancel out each other, and similarly down here in the denominator we have sin beta and sin beta, they will cancel out each other, and then we have sin theta and sin theta, they will cancel out each other, and in the second term in the denominator again we have sin beta and sin beta, they will cancel out each other, and sin alpha and sin alpha, they will also cancel out each other. So essentially we are going to be left with, in the numerator you see cos beta over sin beta. So cos beta over sin beta can be written as cotangent of beta, plus on the second term we have cos theta over sin theta, that will be cotangent of theta, and all of that over in the denominator we have cos alpha over sin alpha, that will be cotangent of alpha, minus we have cos theta over sin theta, that will be cotangent of theta. And from here if we cross multiply, then we can say m times cotangent of alpha minus cotangent of theta is equal to n times cotangent of beta plus cotangent of theta. And now let's remove the parenthesis. So on the left hand side we are going to get m times cotangent of alpha minus m times cotangent of theta is equal to, on the right hand side it would be n times cotangent of beta plus n times cotangent of theta. And now let's multiply both sides by a negative 1, so it will become negative m times cotangent of alpha plus m times cotangent of theta is equal to negative n times cotangent of beta and minus n times cotangent of theta. Next, I am going to combine the cotangent of theta terms together. So on the left hand side we are going to keep m times cotangent of theta, and then from the right hand side I am going to bring the n times cotangent of theta to the left hand side, so that will become positive n times cotangent of theta, and that will be equal to, now let's bring m times cotangent of alpha from the left hand side to the right hand side, so that will become positive m times cotangent of alpha, and then we have negative n times cotangent of beta, and from here let's take cotangent of theta as a common factor, so we will be left with m plus n times cotangent of theta is equal to m times cotangent of alpha minus n times cotangent of beta, and that's exactly what we needed to prove. And also sometimes you will see that this is being written as cotangent of theta is equal to m times cotangent of alpha minus n times cotangent of beta over m plus n. Both of them are the same thing actually, there is basically no difference, just the look and feel is different. Next we are going to prove the next formula, which is m plus n times cotangent of theta is equal to n times cotangent of b minus m times cotangent of c. So let's do that proof. Now let's look at the triangle ABD. So from there we can say that angle B plus angle alpha plus angle pi minus theta is equal to pi, and from here if we try to express alpha in terms of the angle B, then we can say alpha equals, the pi and pi will cancel out each other on both sides, so it will be theta minus B. And similarly let's look at the triangle ADC. From there if we try to express the angle beta in terms of angle C and theta, from that triangle we can say that theta plus beta plus angle C is equal to pi, and from here we can say angle beta will be equal to pi minus c plus theta. Now again we are going to do the sine law on triangle ABD and ADC. So first we are going to use the sine law on triangle ABD, and there we can say BD over sine of alpha is equal to AD over sine of B, and from here we are going to write it as K times M, because BD is equal to K times M over sine of alpha. In place of alpha I am going to write theta minus B, so this will be sine of theta minus B, and that is equal to AD over sine of B, and from here what would be K times M, that will be equal to AD times sine of theta minus B over sine of B. Let's also do the sine law on the triangle ADC. So we can say DC over sine of beta is equal to AD over sine of C angle, and from here what is DC? Well, DC is actually K times N, and in place of sine of beta I am going to write sine of pi minus C plus theta, and that is equal to AD over sine of C, and from here what would be the value of K times N? It will be equal to AD times sine of pi minus C plus theta, that can be written as sine of C plus theta, because sine of pi minus any angle is equal to sine of that angle. So I am going to write it as sine of C plus theta, all of that over sine of C. Next we are going to divide K times M by K times N. Essentially we are going to divide these two equations. So let's see what happens. So if we say K times M over K times N, that can be written as AD times sine of theta minus B over sine of B divided by AD times sine of C plus theta over sine of C, and this can be written as AD times sine of theta minus B over sine of B multiplied by sine of C over AD times sine of C plus theta. And as you can see, this AD in the numerator and the AD in the denominator, they will cancel out each other, and we are going to be left with, in the numerator we will have sine of C times sine of theta minus B over sine of B times sine of C plus theta. Next I am going to expand sine of theta minus B as well as sine of C plus theta. So this can be written as sine of C times sine of theta times cosine of B minus cosine of theta times sine of B, and all of that over sine of B times sine of C times cosine of theta plus cosine of C times sine of theta. And if we remove the parenthesis, then it's going to look like this. Next we are going to divide both the numerator and the denominator on the right hand side by sine of B times sine of C times sine of theta. So if we divide the numerator and the denominator here by sine of B times sine of C times sine of theta, then it's going to look like this. Now if you look at it carefully, you will see that in the numerator this sine C will cancel out this sine C there, and this sine theta will cancel the sine theta. Similarly this sine C will cancel this sine C, and this sine B will cancel this sine B. Now let's look at the denominator. Here again sine B cancels the sine B, sine C cancels the sine C, and then the sine B here will cancel the sine B, and the sine theta will cancel the sine theta. So essentially we are left with cosine of B over sine of B, that can be written as cotangent of B, minus cosine of theta over sine of theta, that can be written as cotangent of theta. All of that over cosine of theta over sine of theta, that can be written as cotangent of theta, plus cosine of C over sine of C, that can be written as cotangent of C, and this quantity is actually equal to M over N. So from here if we cross multiply, then we can say M times cotangent of theta plus cotangent of C is equal to N times cotangent of B minus cotangent of theta. And let's remove the parenthesis. So on the left hand side we are going to get M times cotangent of theta plus M times cotangent of C, and on the right hand side we are going to get N times cotangent of B minus N times cotangent of theta. And now I am going to bring the cotangent of theta terms to the left hand side. So we can say M times cotangent of theta plus N times cotangent of theta is equal to N times cotangent of B and minus M times cotangent of C. And from here you can see that cotangent of theta is a common factor on the left hand side, so we can write it as M plus N times cotangent of theta is equal to N times cotangent of B minus m times cotangent of C. And that's exactly what we needed to prove. Also, sometimes it can be written like this: cotangent of theta is equal to n times cotangent of B minus m times cotangent of C over m plus n. So we have been able to prove both the formulae. These formulae come very handy when solving triangles. We are going to take an example now. Let's suppose we have an example like this. For a triangle ABC, there is a point D on the line BC that divides the line BC into 1:2 ratio. And also we have been provided that the angle ADC is 60 degree. And also we have been provided that cotangent of B plus cotangent of C is equal to 2 times square root of 3. From this information, we have to find out what type of triangle it is. From the look and feel of this example, I feel we should be able to use the ratio formula or the MN theorem. So what are the given information in this example? Well, m/n is given as 1:2 and theta has been provided as 60 degree. And also we have been provided with one additional information, that is cotangent of B plus cotangent of C is equal to 2 times square root of 3. When you say angle B or angle C, we are going to follow the same convention for a triangle, that in this case angle ABC is the angle B and angle ACB is the angle C, and of course angle BAC is the angle A. So using the MN theorem, we can then say that m plus n times cotangent of theta is equal to n times cotangent of B minus m times cotangent of C. Now let's plug in the values here. m/n is 1:2. So if we assume that m is equal to 1 times k and n is equal to 2 times k, then we can say it like this: 1 times k plus 2 times k, assuming that m is equal to 1 times k and n is equal to 2 times k, where k is a real number. We can write it like this, and then times cotangent of 60 degree is equal to, in this case n is 2k, so that is 2k times cotangent of B minus m is 1k, so that is k times, or I can say 1k times cotangent of C. In fact, I don't have to write the 1, but still I am writing it. And from here, let's simplify this. On the left hand side, we have 3 times k times cotangent of 60 degree, that is 1 over square root of 3, is equal to, on the right hand side, we can take k as a common factor out. Then we have 2 times cotangent of B minus cotangent of C. And as you can see, the k on the left hand side and the k on the right hand side, they will cancel out each other. So we are going to be left with 3 over square root of 3, that is actually square root of 3, is equal to 2 times cotangent of B minus cotangent of C. And from here we can just write it like this, that 2 times cotangent of B minus cotangent of C is equal to square root of 3. And also we have been provided with another similar looking information here, that cotangent of B plus cotangent of C is equal to 2 times square root of 3. And here we have found that 2 times cotangent of B minus cotangent of C is equal to square root of 3. So now let's simplify these two equations. So here I am simply writing cotangent of B plus cotangent of C is equal to 2 times square root of 3, and I am simply going to add them up, and we are going to get 3 times cotangent of B, cotangent of C, positive and negative, they will cancel out each other when we add them. Then we are going to be left with 3 times square root of 3. So from here we can say then cotangent of B is definitely equal to 3 times square root of 3 over 3, and that is equal to square root of 3, and that is equal to cotangent of 30 degree. And from here we can say then angle B is equal to 30 degree. Alright, let's try to find out the angle C using the given equation, where we have cotangent of B plus cotangent of C is equal to 2 times square root of 3. Here let's plug in the values. We have cotangent of B is actually 30 degree, so cotangent of 30 degree plus cotangent of C is equal to 2 times square root of 3. And from here we can say that cotangent of 30 degree is actually equal to square root of 3 plus cotangent of C is equal to 2 times square root of 3. And from here cotangent of C will be equal to 2 times square root of 3 minus square root of 3, that is equal to square root of 3, and that is essentially equal to cotangent of 30 degree. So from here we see that angle C is also equal to 30 degree. Now think about it, angle B is found to be 30 degree and angle C is also equal to 30 degree. That means it is an isosceles triangle where AB and AC, they are equal sides. And also how to be the value of angle A? Well, angle A will be equal to 180 degree minus 30 minus 30, so that would be 120 degree essentially. So this is an obtuse angle, and also it is an isosceles triangle. So what type of triangle it is? So we can say that it is an isosceles triangle and also it is an obtuse triangle. I hope everything made sense. Thank you for watching. See you in the next video.